requirements. Let's start with performance. And if we think back to the discussion we had about the CAP theorem, where it turned out that NoSQL databases have enhanced availability over relational databases, but at the cost of diminished database consistency, that would sort of imply that NoSQL databases always perform better. The reality is they do perform better, but in very specific kind of web scale scenarios where the load on the system is huge, and the necessity of what must be retrieved and saved is actually rather straightforward and simple. In those situations, NoSQL databases work well and will perform faster than a lot of relational databases. But in other contexts where we don't have that kind of load, NoSQL databases may actually be slower, quite a bit slower, in fact. So in general, for line of business application loads, you're going to want to use relational databases. They'll be just as fast and probably faster. Plus, because of the consistency guarantees, they'll be much more reliable. And for a business application, that may be something that's not a luxury, but rather a necessity. On the other hand, in those cases where you have the simple storage and retrieval, but you have to do an awful lot of it, then NoSQL may be best. Appropriateness, which really translates into the idea of having examples of where one or the other works well. Think about just the example of storing and retrieving configuration data, personalization data, environmental data for the way an application ought to come up and look and be skinned and be branded. All kinds of settings data, the kinds of things that would probably get stored in a flat file if it were just a desktop application that needed to save and retrieve them. These are the kinds of things that tend to work pretty well for a NoSQL database. Also, log data or any event-driven data, although you will very often find relational databases used for those kinds of workloads, NoSQL databases in many cases will be a more appropriate choice. On the other hand, if you think about anything really that's transactional, especially financial transactional applications, anything to do with stock trades, accounting, credit card transactions, these are things for which using a NoSQL database would really be a bit obtuse. You can probably use relational for anything, and you can probably use NoSQL for anything. There's a law of computation that basically says any problem can be computed in any language, and by extension, that likely means any data requirement can probably be satisfied by any database. But it wouldn't be satisfied especially well. So realize that while there is overlap, there are gray areas. For the most part, things are rather mutually exclusive as to where each of these types of databases works well. And one sure way to come up with a bad decision is to try and come up with an endorsement for one or the other in every single case. That will almost always get you in trouble. The real question is whether the scenarios where relational works best are ones that you see in your business, or whether the scenarios for NoSQL are the ones that you see in your business, or whether you see a mix. If you only see one set of scenarios, then yes, it will appear that one database type is always the answer. But that's because the questions that you're asking are in effect limited. Now let's see if we can summarize the criteria that would together constitute an endorsement for either NoSQL or relational databases. And these criteria are going to break down into a few different areas. We're going to look at financial criteria, and that's pretty new. We haven't really gone over that yet in this course. We'll, in effect, review issues of demand or load on the system and the type of work, the workload that the system needs to take on. Now, on the financial side, we're going to have some fairly novel conclusions here. The first one is the less novel of the two, and that is that the economics of open source software may, in and of themselves, create a strong endorsement for NoSQL. Now, there are open source relational databases, of course, MySQL and PostgreSQL are the key ones among them. But much of the work that goes on in the relational world is still the province of the commercial packages from Microsoft, Oracle, and IBM. The thing about open source software is, of course, it's not free. There's still going to be all kinds of costs around talent and the operation of the databases. But your costs tend to increase with your personnel, whereas with relational databases that are acquired under commercial licenses, your costs will tend to increase with your customer base. And for certain companies, that kind of financing works out just fine. For other companies, it really doesn't, especially if you're headed into that web scale world where your customer base in number can grow to be quite huge. Another facet of the financial discussion is understanding what is going to motivate and impress venture capitalists. And in the startup world right now, NoSql databases are somewhere between hot and just almost assumed. So if you're trying to look for funding, you may find that you have more success if your architecture is based on a NoSql database rather than a relational one. The relational one to a venture capitalist may seem old-fashioned, and thus, for whatever reason, it may not pass certain litmus tests of due diligence. Now, that may seem absurd and really kind of outrageous, and honestly, it may be, but it's important to bring it up because ignoring it as a factor would be, honestly, would be wrong. Now, if you can combine those factors with the real technologically supporting factors, for example, you're in a web scale scenario and you're doing simple storage and retrieval, well, now you've really got a home run because now you're applying the right technology and you have some political and financial reasons that only enhance your choice. So look, if you're not in that demand or workload scenario, then it may be kind of bankrupt in terms of your integrity to use NoSql just to attract a VC. And most likely the smart VCs would probably recognize that. But if you're in the right scenario zone, then on top of that, you're probably going to have a better fundraising experience and an overall more manageable set of costs if you go with the NoSql model. Now, what about on the relational side? On the relational side, we're going to have those same three categories, but the financial arguments change. Imagine you're in an enterprise situation where the licenses that you need have actually already been paid for. In that case, the whole open source argument and not having to worry about costs scaling with your customer base, well, those arguments really become a lot less poignant. Also, you may be in an environment, and in most corporate settings, this is probably the case, where most of the talent on staff is extremely experienced with relational databases and is either minimally experienced or not at all experienced with NoSql. So the cost of training and the hit to productivity that you would experience if you shifted over to NoSql, well, gee, that would just be kind of tough. And, as in the other case, you don't want to let financial concerns completely drive your decision-making process. But if you've got the right technological criteria and you've got issues of training and productivity, well, then you really know what to do. Your choice becomes clear. On the demand side, if we're in an enterprise application or if we're building some kind of business-to-business connection, some kind of software that does data integration on a business-to-business basis, most likely relational is going to work well there. And then finally, if guaranteed consistency is important and if the diversity of the reporting and the query that you're going to be doing is wide, well, then relational is really what you need. Because in a NoSql world where, in effect, you have to write a different program for every query, I'd have to say that doesn't scale especially well. So the use cases are pretty clear here. The financial dimension to this makes things a little bit more nuanced, I suppose. But really, you'll find, I think, that the financial concerns really will align properly with the business case and the technology case, no matter what. Now let's talk about how NoSQL combines with some other technologies, specifically business intelligence and also big data, things that we've alluded to before but haven't really covered in any great detail. So how does NoSQL kind of overlap with BI, if at all? Well, on the one hand, NoSQL databases themselves are not very well suited to a BI workload at all. They're not designed for ad hoc query because every query has to be explicitly programmed. So you're not going to use a NoSQL database as a data warehouse. You're not going to use it for ad hoc reporting. It's not a BI technology. Not only that, but BI applications typically involve semantic models so that when you do your analysis, you can ask questions based on what's actually there in the data. You need a model for that to happen, and in order to have a model, you need schema. So on the one hand, it would look like NoSQL is completely exclusive from BI. But on the other hand, in the world of BI, there is this thing called ETL, extract, transform, and load. And that's really just a fancy way of saying getting data out of operational databases and putting them into special BI databases. And normally that's applied to relational, but it can also be applied to NoSQL. So while NoSQL databases are probably not going to serve the BI workload directly, they can in fact be very valid and useful data sources for specialized BI technologies that will serve that workload. So NoSQL is not something you can literally use for BI, but it is absolutely something that you can use in the BI pipeline. It also turns out that the wide column store variety of NoSQL database has a lot of BI street cred for a couple of reasons. First of all, in the BI world, it's a very cutting edge thing now to be using a database that is column oriented, where all the values of a given column are stored next to each other. Well, it turns out that column oriented BI databases and wide column store NoSQL databases actually have a lot in common. So there is, in the case of wide column stores, there is more appropriateness and applicability than you might think. The other thing to keep in mind, though, is that wide column stores are extremely prevalent and almost used automatically in big data scenarios. So let's talk about those. Big data and NoSQL are absolutely not the same thing. And it's probably the job of another course to define what big data is. But for now, our working definition will be that big data involves the analysis of data sets that are large enough to be disruptive to relational databases and really just not to be handled efficiently by them. And that ought to sound familiar because we've really already said that in extreme scaling situations, NoSQL databases can also handle things where relational databases kind of break down. Our friend the wide column store comes back here again because in big data, the combination of HBase, which is a NoSQL wide column store database, and Hadoop, which is a distributed computing platform for doing analysis by chopping up the work and spreading it over a whole array of machines in a cluster. You put those guys together, you have a pretty typical big data combination. And again, HBase is a NoSQL database. So while the two are not the same, they have an awful lot of interrelatedness. And if you think about it, you know, the kinds of things that make NoSQL databases not great for certain line of business applications aren't really a problem in BI. The lack of indexing isn't a problem because what we're effectively doing in BI is looking at huge numbers of rows and just kind of just aggregating through them. We're not really relying on indices. The consistency isn't a problem because we're not really updating these databases, we're just reading them. Meanwhile, fast reads are important. So what we want, what we're comfortable with, is sacrificing consistency for availability, which is what we've learned is exactly what NoSQL databases do. Distributed file systems are very important and relevant here. The fact that NoSQL databases tend to distribute their data works really well in a big data scenario because it means all those pieces of data on different servers can be counted at the same time by agents on each of those servers, by computing agents on those servers. The fact that NoSQL uses commodity hardware and commodity disks works really well for big data as well, because the way big data is handled is by scaling out across large numbers of nodes in a cluster, and that is really only sustainable if the nodes are based on commodity hardware that is relatively affordable. And although the big data scenario is not a web scale scenario in terms of users, it is still a huge scale out scenario in terms of computation. So the scaling features and strengths of NoSQL tend to work very well in a big data scenario. So we see that there's a decent amount of overlap between NoSQL and BI, and a huge amount of overlap between NoSQL and big data.